Our study now is on rates and ratio. We want to begin with the study of rates and then get to ratio. So rates actually is the measure of how much a quantity changes with respect to time. A rate is always a ratio, and this may include the number of pulses per minute, that's a rate, number of patients a day, that's a rate, reported cases of malnutrition in a month, rate, birth rate. If you look at all this, you see some kind of link with time, which is a very important aspect of talking about rates. Now, in the process of describing rate in a given occurrence, you may realize that there could be change in the rates. We would have initial rate, what we call rate 1, then we new rates in the process, rate 2, and so on and so forth. And you want to assess this kind of dynamics in the process of investigation or monitoring of your occurrence and experience. Then the following terms become useful and common. We have absolute change, which is actually the new rate minus the old rate. That difference gives you the absolute rate change. Now, relative change is actually the new rate divided by the old rate of the experience. Now, if we talk about proportional change, then we have rate 2 minus rate 1 over rate 1. That is basically the absolute change divided by the old rate. These are terms which need to be considered when we are talking about rates. Maybe what you would want to hear is mostly examples related to this. So I want us to do example 1. Records in an institution reveal that in the year 1998, 54 seminars were conducted on the importance of nutrition as a science. If the seminars were well distributed throughout the year, calculate the approximate number of seminars per month in that year 1998. So our main interest is actually to look at the total seminars, which is 54, and because it is distributed throughout a year, which is 12 months, then rates per month will be the total seminars divided by the total number of months. Of course, we will get these values just directly substituted in the formula, and we find 54 over 12, 4.5. So we don't have a 0.5 seminar. So that means we are going to approximate this to about 5 seminars per month. That is a rate which can reflect some information if maybe an institution wants to gauge the number of seminars offered and whether to improve or not. The example number 2 talks about a health center receiving approximately 6 patients per day for meal plans. Yes, how many patients visited the hospital in February 2019? Now this again brings us to an understanding of the number of days in various months in a given year, whether it is leap year or the ordinary one. Therefore, in this case, we're talking about February 2019, and trying to solve this, I think it is advisable that I also bring a copy of that calendar here, so you can see February ended on day 28. So that simply means the number of days in that month is 28, and our rate is 6 patients per day. So in the simple approach, we simply get the total patients during that time would be approximately the product of the rate and the days, which is 6 times 28, which is 168 patients. Very simple questions and very nice ways of trying to understand what we mean by rates. What about ratio? This is basically a way of making comparisons for quantities using division. It also may indicate how many times one number contains another. So sometimes we're talking about comparison of quantities, and normally we have it written in many different ways and read as the ratio of this to that. So like for example, in what we have here, we have x to y. Sometimes you have x out of y. Then we also have x colon y, that it can also be trying to give us how ratios are compared or read. Then you also have, sometimes we use this format to also talk about ratios. So these are things you will commonly meet when you are talking about ratio. And properties of ratios include, they normally have no units. That is, if you are talking about similar quantities, because it's a ratio actually. So the units will divide, and then you will cancel out, then you end up with no unit. It's a ratio. So can be scaled, can be rescaled by a factor or constant multiplication. So when that happens, then you can have the ratios modified. So these ratios are normally greater than 0. Especially it's hard to come by a negative ratio. Yes, so that is basically why we are saying they're normally greater than 0. So can be used to figure out probabilities. Can be used to figure out probabilities. These are also part of statistical studies, and therefore ratios are important as far as these studies are concerned. Now there is this statement which needs to be understood. Equal quotients correspond to equal ratios. This simply means that if I have a ratio A to B and the other one C to D, and then we have A to B equals to, or we have A over B equals to C over D, then the ratio A to B equals to ratio C to D. That can be used to determine the missing parts of some of these things. When we are going to do proportions, then you'll come to understand the meaning of this statement in a better way. Now, a quotient of two quantities that are measured with different units is a ratio called a rate. When you introduce different units, then this ratio transforms into something called rate. If especially when the other unit is with respect to time or other quantity which we wanted to see a trend with respect to that quantity. So it is easier using ratios to describe this, and that can define to us a rate. Now the numbers x and y from previous slides, you know what I meant by that, are sometimes called terms of the ratio. Terms of the ratio, with x being an antecedent and y being the consequent term. So this is actually but just naming of parts of a ratio. Let's do an example under the ratio part. 63 male patients are in a medical camp where the ratio of male patients to female patients is 3 to 4. How many female patients are present in the camp? Okay, so the ratio of male to female is 3 to 4. Then we have 63 males, therefore we can easily get the females. The first approach is actually to look at the total ratio. So we have male to female 3 to 4. Males are 63. Total ratio is actually this 3 plus 4 to get 7. So in other words, 3 all over 7 gives us the males, which is 63. While if you want to find females, that is actually the fraction for males taken away from the whole fraction, the total. So we have 1 minus 3 over 7, or sometimes you can say 7 over 7 minus 3 over 7 to get 4 over 7 for females. So you ask yourself, if 3 over 7 gives us 63, what about 4 all over 7? You just do some cross multiplication, then you end up with 63 times 4 over 7, what we want, divided by 7 by 3 over 7, which turns out to be multiplication of 7 over 3. So this is equal to 21 times 4, which is 84 females. Very simple ways of trying to look at this. Question 4. In March, that is a month, 224 patients were tested for malnutrition. If 40 of them were females, okay, and 4 were intersex. This is another gender which is being accepted by various countries, so we need to also take into consideration of this, if this is a case of that country which has accepted this. So we have 40 of them being females and 4 intersex. Determine the ratio of males to females tested in that month. Total tested to 24. Yes, females 40, intersex 4. So that simply means if you want to know the number of males plus the intersex, you'll remove the females. That is 224 minus 14 minus 40, you get 184. Males only will be this total 184 minus the intersex total 4, which will be 184 minus 4, you get 180. So if I talk about a ratio of males to female, then I have already found males to be 180 and the females were given as 40. Then males to female will be 180 to 40 ratio. And then you don't leave ratios like this. We have to simplify this. So that can be 18 to 4 by just dividing by 10 throughout. Then this actually dividing by 2 throughout, you get 9 to 2. So this is actually the ratio of males to female in this kind of test experience. So our next will be on proportion and percentage. Thank you.